Okay, good. So we're not recording my football picks because I don't want you guys to record my football gambling tendencies. Let's talk about confidence intervals. So yes, these learning objectives: construct confidence intervals for a population mean, construct confidence interval for a population proportion, interpret it, and decide what confidence level to use depending on the severity. We didn't really do that so much, like determining which one to use. Like we just kind of said, hey, do 90% confidence, do 95 or 99, whatever. But definitely interpret the intervals, yes. And determine the minimum sample size, a guarantee, absolutely. So definitely I'm going to expect you guys to know this. This you should know, but not this. Don't worry about that. This for sure, and this for sure. So yeah, so those are things for sure we need to know. Now formulas, remember, to do for a population mean, you take the X bar plus or minus the Z score times sigma over root n. In case you guys forgot, X bar is a sample mean. So you're going to survey, right, some people, and you're going to get a mean for it, but it's not going to be the population mean. Like if I were to survey a bunch of like high school teenagers in, say Atherton or say Menlo and Sacred Heart, so we do a combined survey. I want to know the average hours they sleep per night. I can get, yes, it would be great to know the population average hours of sleep per night, but I'm just going to get a sample, right? Maybe I'll survey 50 people and I get a sample. Actually, it'd be interesting to see if there's a difference between the two. That's another test, which we'll talk about that down the road when you are comparing two different populations. Of course, Z is a Z score. Depends on confidence level. Whether you do like 90, 95, 99, or whatever. Sigma is the standard deviation. And N is going to be the sample size. Okay, I'll give this to you, and I'll even tell you what these things mean also. I mean, you should know, but I'll tell you. Not a big deal. Then for the next part, if it's a proportion instead, like you're curious to know, like, hey, what percentage of people might vote in a certain election? We do have a gubernatorial race this year, so Gavin Newsom has to run. He had a recall, but he has to run for re-election. What is his chances of getting reelected? It's interesting because the homelessness is getting worse, the wildfires are getting worse. I don't know. We shall see if someone challenges them, but that's going to be p hat. So because that's the case, we're looking at proportion percentages, right? Usually when you're looking at political polls, it'll be p hat z plus minus z times, and this is one big radical. It'll be p hat times 1 minus p hat over n. And p hat, just is a sample proportion. So if you're to sample a bunch of people, like and ask them, are you going to vote for Gavin Newsom or not? Whatever percentage of people said yes, they would. That would be your sample proportion. If you survey 100 people and say 60 of them said yes, you would say 0.6 is your p hat. So those are the formulas you need to know. And I'll give these to you, so not that hard. And also I'll give you the Z scores. So I'm going based off memory. I'm pretty sure this is 1.96. It's like 2.5. I should know this. Yeah, this is where. Yeah, Z score, confidence interval. Yeah, it's 1.65, 2.58. So anyway, that's what we got there. So let's go to the question. I'll probably erase this stuff. That's really distracting. I'll erase this also. Okay. So here, the research has been finding a 95% confidence, and you can't know these formulas. So just I will. But, so research is to find 95% confidence for the mean number of times per day called in this text. Okay. That's kind of a good one. The study for turn intentions to average 28 text per day. Okay, so maybe like let's say do this at Stanford University or Cal, and it's like 10,000 students on the campus, but you're only going to survey 210 students. Fine. Standard deviation is 21. You have the mean sample. So the computer confidence interval use a normal distribution. So we haven't done T, so don't worry about T. We haven't done a T distribution. I haven't talked about what that is. But remember, confidence intervals assume normal behavior or a normal distribution, meaning a bell-shaped curve. That's what it assumes. With 95% confidence population is between, okay, well, we have to actually work this out. So remember, X bar plus or minus Z times sigma root n. So if I were to work this out, X bar obviously is going to be 28. We'll change colors so it stands out. 28 plus or minus Z, which is for 95%, we got is 1.96 times sigma, which is 21. And you're doing this with 210 students. Very, very easy. Now we will need a calculator. I'll have an extra calculators for you guys. But feel free to bring your own. So let's work out this bad boy here. 21 divided by root 210 times 1.96, 28 plus that number. So you get 28 plus or minus 2.84. So if I look at it, definitely it's going to be 30.84, or that's close enough. If I subtract, that's like 25.16. That's close enough. So I feel pretty good about that. And then for part C, if many groups of 210 randomly selected, so let's say you repeat this survey like 100 times, right? Then you expect 95 of those intervals that you're creating, because you're creating, you're doing this 100 times, so you're creating 100 different intervals. But 95 of those intervals should contain the true population mean of number of texts college students send per day. So about 95% will contain true population mean, and 5% would not contain it, right? So that's what's going on there. So that should be pretty straightforward. Okay, so this one involves the same thing. So what I like you guys to do, because it looks like most of you guys have devices. Obviously, Brianna's got a device because she's at home. But I see Luke has one, and then you have one. So why don't you guys click on the link, tell me what you guys get for number 2, and we'll see if we get the same answer. And I'll pause the video because there'll be a bit of a silence. Darn it. That sucks. Okay, so we're back to recording. Okay. My apologies if you didn't see the other ones, but that's okay. Anyway, really quickly, just a recap. So my number 8 here was true. My number 9 here is true. My number 10 here was false, because it's not a 5% chance. Don't worry about T distributions. We did 12 and 13 of those sample proportions. Anyway, for this one right here, for number 17, margin of error of 10 is going to equal the z-score we're using was 1.96. And we're not using this formula, obviously, because it's z times sigma over root n, because that's one where we have a sample mean. So standard deviation over root n, which is going to be 75 over root, well, I don't know what n is. We got to solve for it. So 10 root n equals whatever 1.96 times 75 is, which of course is 147. Root n equals 114.7. N equals where that is squared, 14.7 squared. So you have about 216.09. So you probably need about 217 bytes. Just use your round up, So you need about 217. So it's just a little algebra. The other ones are kind of the same thing. Obviously, if it's dealing with proportion, so this was, I think, probably dealing with proportions, plus or minus 3 percentage points. because you don't have, yeah, then you want, yeah, and I think you want a sample size of 0.5, or sorry, a percent proportion of 0.5 to get a majority. So you'd have something like this here. Root 0.5 times 1 minus 0.5, and then of course n on the bottom, z, and that's going to be 0.03. You would do that then. So it worked like that. So anyway, well done, and I will see you guys on Thursday. I'm available upstairs tomorrow if you want to come by, or otherwise see you on Thursday.
Thank you, Mr.
I'll have my NFL predictions pretty as well. So.